Hey guys, welcome to ChemLab. Have you ever wondered why oil and water never mix? Some people say it's density. But let's say you pour out the oil and water. Why won't it mix? Maybe the answer lies in the concept of molecular polarity. Now in molecular polarity, there are two types of molecules. It can either be polar or non-polar. Now let's talk about polar molecules. Polar molecules are usually asymmetric. They contain lone pairs of electrons on their central atom, and they have atoms with different electronegativities. Now let's check some examples. Let's say water. Now, water has lone pairs in the oxygen atom, and they have different electronegativities. Therefore, it is a polar molecule. Now, unlike polar molecules, non-polar molecules are symmetric and they are bonded to the same element with no unshared pairs of electrons. Some examples are all diatomic elements, and I'm talking about, let's say, hydrogen gas, oxygen gas, or even nitrogen. Let's check out ethane. Ethane, more than it not having unshared pairs of electrons, no matter how we slice it, it's still symmetrical. Now let's see molecular polarity applied to the concept of intermolecular forces. Intermolecular forces are the forces of attraction or repulsion which acts between neighboring particles. It can be atoms, molecules, or even ions. There are 6 of them, so let's start with the dipole-dipole interaction. This exists between two polar molecules. The force that occurs when the partially positively charged part of a molecule interacts with the partially negatively charged part of another molecule. Dipole-induced dipole interactions exist between polar and nonpolar molecules. The polar molecule and a nearby nonpolar molecule cause the electrons of the nonpolar molecule to be distributed on one side, allowing the other side to be distorted. This movement can cause asymmetry and can therefore induce polarity. The ion-dipole interaction exists between an ion and a polar molecule. See the example in the dissociation of table salt in water. Next is the ion-induced dipole, which exists in an ion with a nonpolar molecule. It is caused by an approach of ions in nonpolar molecules, resulting to an induced dipole. Hydrogen bonding is a special type of dipole-dipole interaction that exists in polar molecules. It is when H bonds with highly electronegative atoms, and it is known to be the strongest bond there is. Lastly, we have the London dispersion forces. These exist in both polar and non-polar molecules, in short, in all species. Let's see how this applies to the different properties of a liquid. Now, water has hydrogen bonds. It can be observed that it can bead up because of the high surface tension. Honey is also strongly hydrogen bonded, and it's highly viscous due to its strong cohesion. Vapor pressure is a measure of the pressure exerted by a gas above a liquid in a sealed container. Basically is the speed of evaporation. Highly volatile liquids usually have high vapor pressures. Now, the greater the intermolecular forces are, the lower the vapor pressure. The weaker the intermolecular forces are, the higher the vapor pressure. Now, the boiling point is the temperature at which its pressure is equal to the external atmospheric pressure. Now, when you have strong intermolecular forces, more energy is required to break it down. Therefore, higher the boiling point. Let's look at some properties of solids. There are two types, namely crystalline solids and amorphous solids. Crystalline solids are solids that exist in a regular, well-defined arrangement. We have ionic solids, molecular solids, atomic solids, and metallic solids. Amorphous solids are solids that are not arranged in a regular order. A prime example is the plastics you use every day that kills the environment. So stop using it. Stop that. Do you remember the question in the beginning of this video? On why oil and water won't mix? It's not merely density, but because of their different polarities. You see, oil is a non-polar molecule and water is polar. They just won't attract each other. They have different polarities and that's why they won't mix. That's all the time I have, chemists. See you next time in Chem Lab.